Okay, so let's take a look at the PE handout, number 1. And for this one, we had some absolute value inequalities. So let me maximize the screen here. And let's see. So the first one that we have is 4 minus 3x in absolute values, minus 2 is less than 4. So the first step is always going to be isolate the absolute values. So 4 minus 3x is less than 6 when we bring the 2 over. And now there are a couple things you can do. When it's less than 6, when the absolute value is less than 6, you can do one of two things. Some people like to solve it all at once with a compound inequality. And then I've noticed some students prefer to do something like this. So let me shrink this down. Some students prefer to do this. They like to split it into two different things, where it turns into 4 minus 3x is less than 6, and 4 minus 3x is greater than negative 6. That's fine if you want to do that, but anytime you split an inequality like that with absolute values, you got to tell me and or. And in this case, since it's less than 6, we're looking at, on a number line, stuff that's going to be between 6 and negative 6. It's going to be the stuff in the middle here. So that, since I can pick a number that's both bigger than negative 6 and less than 6 at the same time, this is an and. So if you want to do it that way, that's fine, but you have to tell me and then in this case. Otherwise, do it this way. Okay, so either way we're going to get the same answer. So let's work out this compound one over on the left. So I'm going to subtract 4 from all of them. So negative 10 less than negative 3x less than 2. And then I'm going to divide everything by negative 3. So I'm going to get x. And when I divide by negative 3, since it's a negative number, I got to flip all my signs. And so this becomes positive 10/3 on the left, negative 2/3 on the right. And so I'm going to get rid of this here. So we need to write the solution in interval notation and draw the number line. Well, in interval notation, since it's not inclusive, I'm not going to use the brackets. Instead, I'm going to use the parentheses. The low number is negative 2/3. The high number is 10/3. And then on a number line, this would look like this. Here's negative 2/3. Here's 10/3. It's open dots, and it's everything in between. For number 1b, we have another absolute value. This time it's a greater than version. Okay, so a greater than version means it's going to be everything that's, like if all I had was this, x is greater than or equal to 3, well, numbers that would work would be 3 and up, so everything here and up, and negative 3 and down, right? And this one's really an or, because I can't pick a single number that's here and here at the same time. It's got to be in one or the other one. So let's split this up. It's x plus 2 over 3 is greater than or equal to 3, or x plus 2 over 3 is less than or equal to negative 3. So let me get rid of all this stuff. If I multiply both sides by 3, I'm going to get x plus 2 is greater than or equal to 9. So x is greater than or equal to 7. Or I have x plus 2 is less than or equal to negative 9. So x is less than or equal to negative 11. On the number line, here's negative 11. Here's 7. I'll switch colors. Greater than or equal to 7, so that's a filled in dot. It goes this way. Less than or equal to 11, filled in dot at 11, goes this way. And when I write this in interval notation, it's everything from negative infinity up to negative 11, including the 11. Or, remember, union is the same thing as or here, 7 up to infinity. And the 7's included.